So synthetic division, you guys remember how this works? So we take this piece that we're dividing by, and again, this only works if it's a linear, we're dividing by a linear factor. So if this had been an x squared plus 8, the deal's off. We'd have to do the long division that we just did a second ago. But we can get away without doing that big old mess if it's a linear factor. What you need to do is find the root of this linear factor by setting it equal to 0 and solving. I don't care if you do this part in your head. I don't need to see the work for this. If you can look at x plus 8 and tell me that the root is -8, you don't have to write down x plus 8 equals 0 and show your work for solving, okay? But would you agree that if I did write x plus 8 equal to 0 and solve it, I'd get -8 for x? And that's the root. That's the 0 of that factor. A root or a 0 is what you get when you take the thing set it equal to 0 and solve it. All right. So that -8 is going to go in a little box over here to the side. Did you guys learn this last year? Does this look familiar? Yep. And then we take and line up our coefficients only. We leave all the x's out after this. Now, before we do this, we want to check and make sure that we're not missing any terms. And this one is not missing any terms. Do you know what I mean by missing terms? Like if there hadn't been an x squared term in here, we need to insert a 0 in that spot. I encouraged you to do this when we were talking about long division. It is absolutely necessary when you're doing synthetic division. The number one source of errors with synthetic division is people forgetting to put those zeros in. All right. And then we're going to leave ourselves room for another row of numbers underneath that and draw our line. And I do this thing with the little box at the end. Is that the same style that you did last year? Some people do it a little differently. And when we get done, what is going to appear in this little box right here? That's our remainder. And everything else, we're going to have to do a little translation to figure out what all it is. But yeah, so from here, then we basically do the same steps that we did when we were doing long division. We add and multiply. We add and multiply. Actually, we don't need to do the division step. So first thing I do is take that first number and that gets just dropped down immediately. That comes straight down. So that's 5. Right, we always add going straight down, and I kind of think of this as still adding going straight down. It's just there was nothing to add to the 5, so it just went straight down. So we add going straight down, and then we multiply going up and diagonal. And we always multiply by the same thing. What do we multiply by? -8. We always multiply by -8. Whatever's in our little box up here. So 5 times -8 is -40. And then we add going straight down. -41 plus -40 is 1. And then we multiply going up diagonally. We always multiply by the same thing. Whatever's in the box. In this case, that ends up being -8. 1 times -8 is -8. And then we add, then we multiply, then we add, then we multiply, and then we add, and we multiply, and we add one more time, and we're done. So keep going there. That gives us 7. 7 times -8 is -56. Which is where I screwed up when I was doing the long division. 63 plus -56 is 7 again. 7 times 8 is -8 is -56 again. 64 plus negative 56 is 8. 8 times negative 8 is negative 64. 55 plus negative 64 is negative 9. Were you able to get negative 9 for the remainder? All right. And then we would translate this into our final answer. So that's not an answer, that's kind of our answer in code. We need to put some x's and x squareds and stuff after it. So remember, whatever this is going to be your constant. So you got your remainder in the box, and then it goes constant. This would be your linear term, your quadratic term, your cubic term, your fourth power term, your fifth power term, and so on. A lot of my students will get in the habit of writing those x's and x squares and everything underneath, because it just makes writing the final answer a little bit easier. But our final answer is 5x to the fourth plus 1x to the third plus 7x squared plus 7x plus 8 plus, and then remainder of negative 9 always goes over the thing that we were dividing by. We were dividing by x plus 8. And that would be our final answer, which is exactly what we got during long division. But man, we could do that so much faster, right? Isn't synthetic division great? Cool. I want to do one more. Give me just a moment to, I should have written it down ahead of time, but I didn't, so my apologies. All right. I'll read it and then I'll put it up on the screen here as well. I can't do it. Okay, so it's going to be x to the fifth plus x to the fourth minus 90x to the third plus 6x minus 56 all over x minus 9. I'll put it up on the screen here. X to the fifth plus x to the fourth minus 90x to the third plus 6x minus 56, all divided by x minus 9. And I wanted to do this one in particular because what do you notice about the thing on the top this time? What do you notice? There's no x squared in there, right? Did you catch that? There's no x squared in there. And if we're going to do synthetic division, we have to fill in all of the terms. So I'm going to insert a plus 0x squared in that spot. And when I put my numbers, my coefficients in there, that zero's got to show up. Are you all comfortable looking at this x minus 9 and just throwing that positive 9 straight into the box there? That works for you. My coefficients are 1, 1, negative 90, 0, 6, and negative 56. And go ahead and work it out. Let's see what we get. Ooh, like all those zeros. Question. Say again. Oh, I did. 9 times 6 is not 56, is it? Bummer. I was hoping to get a remainder of 0. Wishful thinking. It is 54. Thank you. Which means my remainder is not 0, it's -2. Ah, bummer. All right, so we don't have to worry about any x's or x squareds. We got an x to the 3rd and an x to the 4th. So, final answer. Does that look better? Mm-hmm. I'll get to that in a second. Short answer, no. I'm not going to collect those. But I'll talk about that in a second. All right. That's our Algebra 2 topic from the day. We got an Algebra 1 to go over too. You ready for this? Yeah. Are we good on synthetic division? Yeah. All right. Ready for some good Algebra 1, some good linear stuff? It's going to be great. All right. We're going to just make up a problem for this. So we are going to write a function in the form f of x. No, we don't need to graph this even. F of x equals something. And I'm going to give you some information about this function. Okay. So our goal is to write a function. I'm going to tell you that f of 2 equals, someone give me a number between 10 and 20. 18. F of 2 is 18. And f of -5 is, someone give me a number between 20 and 30. 30. Between 20 and 30. That'll work. 30 will work. All right. Do you remember doing this from Algebra 1? They didn't word it this way in Algebra 1. Well, you guys did Algebra 1 during COVID, though, didn't you? That was shutdown year. All right. Okay. No biggie. That's why we're going over it. This is essentially the same as write me an equation of a line that goes through the points. Can someone give me the coordinates of our first point? 2, 18, right? Because if f of 2 equals 18, that means when I plug 2 in for x, I get a y value of 18. That's what that means, right? Goes through the point 2, 18 and -5, 3. We're just writing the equation of a line. Y equals mx plus b. Do you remember doing this? Yeah, we spent a whole bunch of time on it. Do you all remember the slope formula? Subtraction, it's got subtraction in the top and the bottom. Y1 minus y2 over x1 minus x2. Did anybody learn it? Y2 minus y1 over x2 minus x1. Same thing. As long as your ones line up and your twos line up over top of each other, as long as you got your y's on the top and your x's on the bottom, that'll be fine. I like to label my points to make sure I get everything in the right spots. Double checking I got everything in the right places here. I think I'm good. 18 minus 30 is -12, if I'm not mistaken. 2 minus -5 would be the same as 2 plus 5, that's 7. So we've got a negative slope, 12 over 7. That's not really algebra 1 level slopage, but that's okay. We're at pre-calc now. We can deal with nasty slopes. We got this. We got this. Now all we got to do is figure out what B is. Is it 18 or is it 30? It's neither. Yeah. So there's a couple of ways we could do this. If you all learned point slope form would be a pretty easy way to do it. If you know what that is, that's great. Those of you who are saying plug it in, that's awesome. I'm going to go with the plug it in method. This equation is what I know of it anyways right now is y equals, I know it's negative 12 over 7 x plus, I don't know what b is, so I could just leave it as b. You're going to find yourself doing this a bunch in section 2.1, where we'll have most of an equation, but we're missing one little piece of it. And our method for finding it's going to be to go back to one of the points that you know is on the graph. We got two options this time. Plug those in for x and y in this equation and then solve for whatever you're missing. In this case, we're missing b. So I could use this equation right here and just find some values to plug in for x and y. And then I got an equation that I can solve for b. And it doesn't matter which of these we use. I think I'm going to go with the 2 and the 18, just to avoid negatives. But someone else could try the 30 and the negative 5, and you should get the same answer. Ooh, I like your thinking. Maybe we should go with this. Because you're thinking ahead that we're going to multiply the x times the negative number, and then we won't have a negative number to deal with. You know what? I'm going to switch my tack and go with you. Thanks, Jonathan. So I'm going to, yeah, I like this. I like this. Thinking 2 steps ahead there. I'm going to go with the negative 5 because then the negative times the negative will cancel and get a positive. Yeah. And the 30 over here for the y. Could have used 2 and 18. What do we got? 30 equals negative 12 over 7 times negative 5. It's going to turn out positive. 12 times 5 is 60. 30 equals 60 over 7 plus b. 60 over 7 simplifies. And then we just got to subtract on both sides. And this is a great opportunity for me to show you something really awesome on your graphing calculators. Why don't you get those out? Some of you might know this already. Now, you are at the stage in your mathematical careers where I would expect you to be able to do 30 minus 60 over 70 without a calculator. You should be able to pull that off. I would turn that 30 into, what would that be? Something over 7. 30 would be the same as 210 over 7, right? 210 over 7 is 30, isn't it? 210 over 7 minus 60 over 7 would be 150 over 7. Answer is 150 over 7. And you can do it too, okay? But let's do it with the calculator too. So I'm going to type in 30 minus 60 divided by 7. And then ask my calculator to give me my answer as a fraction. So 30 minus 60 over 7. And then under the math button, which is 3 rows down on the left-hand side, you will find an arrow fraction. That tells your calculator that you want your answer as a fraction. So 30 minus 60 over 7. Hit enter. Hey, look, 150 over 7. So B is 150 over 7. And if you did 30 minus 60 over 7 and you didn't do math frac, it'll give you the decimal. But then you can take that decimal and math frac it, and it'll turn it into the fraction for you still. Yes. Exactly. Yep. Yeah, I think the Casios have a fraction button on them. The TIs do not, as far as I know. Or maybe the 89s do. Oh, and it has a fraction. Where do you find it? Alpha, yeah. Oh, okay. Alpha y equals. Oh, look at that. Yeah, that's right. Alpha y equals will get you a fraction too. We'll make you a little fraction. Okay, cool. All right, well, let's finish this up. So our final equation, and now that we know B, our final equation, we had almost all of it here, but let's write down a final equation. Alpha of x equals, instead of y equals, negative 12 over 7, x plus 150 over 7 for the win. All right. All right, get out whatever you're going to do your homework in. We're going to start our homework now. And most of you will finish it. Hopefully all of you will finish it. And we're going to go ahead and actually we'll add this on to the homework that I assigned after the test. So if you got those 4 long division problems, go ahead and just add this right on to it. So we are going to do, starts on page 182. Page 182, we're going to be doing problems 1 through 12. But wait, there's more. The long division. What did we do? What did I assign you after this test? It was set 3. Okay, we're going to do set 3 and 4. So hopefully you've already done set 3. That's 4 long division problems. Set 4 is, I believe, 8 or 10 synthetic division problems. So it should be pretty quick. Make sure you write out your final answer. And remember, the answers are on the back of that sheet. If you don't have that sheet, it's on Canvas. Can we do a couple of these together, though? The ones out of the book? Okay, let's do that. Number 1 out of the book. I didn't talk about this, but I'm hopeful that you learned this last year. Number 1, the question is this a polynomial, yes or no? Is this a polynomial function, yes or no? Let me zoom in a little bit. Zoom in a lot bit. All right. So let me just go over the rundown of the rules for what makes a polynomial. Okay, a polynomial function is a thing that has terms that are added or subtracted. The exponents in those terms need to be positive integers. No, is that true? They can be 0 also, but they can't be negative integers. Okay. So whole numbers, is that whole numbers or natural numbers? Which one includes 0? Who remembers? I can never remember. Whole numbers include 0? Okay, so whole numbered exponents. So is number 1 a polynomial? No, because of the -5. So for number 1, write no, because of the -5 exponent. So it says explain why or why not. So we would say no, -5 exponent. All right. Number 2, is that a polynomial? Yeah, it is. It is. It's an x to the first power. So for number 2, write yes. Now it asks you to state the degree of the polynomial. The degree is the highest exponent in the polynomial. This would be a first degree polynomial because it does have a 2x to the first power. We don't usually write the first power. It also asks you to state the leading coefficient. The leading coefficient is on the term with the highest exponent. What's our leading coefficient here? 2. All right, 2 problems down. Should we just keep, why don't we just burn through these first 6 together? What do you think? Let's do it. Number 3. What do you think? Is that a polynomial? It is. Yeah, all of the exponents are integers. No negative exponents. So that is a polynomial. Degree. The degree is the highest exponent. So it's a 5th degree polynomial with a leading coefficient of 2. Four is the one that people tend to argue over. So technically monomials are polynomials. This is a monomial. Well, yeah, I guess if it has multiple terms, it would be connected by addition, subtraction. I would say yes, this is a polynomial. What is the degree of the polynomial? It says 0th degree polynomial. We could write this as 13x to the 0th power, right? Because x to the 0 is 1. And that would be the same thing. And the leading coefficient is 13. Now, if you choose to disagree with me on that, I would respect your opinion. In fact, I'm kind of curious to see if the answer, the solutions manual says that it is or it's not. Well, it's even, so it's not in the back of the textbook. But I got the teacher's edition that has all the solutions in it. Yeah. All right, number 5. This is a tricky one. Is anybody tempted to just take cube roots of both of the terms? Anybody tempted to do that? I'm tempted to do that. Man, I wish you could do that, but you can't. You can't distribute a square root like that. So there's really absolutely nothing that we can do to simplify this. So it's not a polynomial because of the cube root. Yeah, and I'm sure this came up on somebody's test, but if you have the square root of x squared minus 4, unfortunately, that is not equal to x minus 2. It just doesn't. It would be so nice if it was. There are so many things in math. Huh? The square root of x squared plus 4 is still not equal to x plus 2. Because the square root is really an exponent, right? Square root's the same as an exponent of a half. And you can't distribute exponents when you have addition. It would be so nice to do that, right? The same way, and this is classic algebra 1 mistake. I'll give my students something like this, and they want to go, what's the wrong answer? They want to go x squared plus 4. But you know that's not right, right? You know that you need to actually do x plus 2 times x plus 2 and FOIL it out, and you get x squared plus 4x plus 4. Right? That's the right answer. This does not. So if I square rooted this, that gets complicated because it depends on if x is positive or negative. Because it's possible I could pick a value for x that would be outside of the domain of the square root. But it would simplify to x plus 2 for any x value that's in the domain of this. Yeah, there would be some domain restrictions on it. Yep. All right, let's finish up. Number 6, polynomial, yes or no? Number 6, heck yeah, definitely. Definitely. Degree? 2nd degree polynomial, lead coefficient? Negative 5. Cool. All right, you're done with 6 problems. You got 6 more to go on there, and those long division and synthetic division, and then that's it. Okay. If you get done, I'll go ahead and put the assignment. I'll put the first assignment for chapter 2 up here. This is not due. And the thing I'm going to put up on the board here is not due on Monday. It'll be due on Tuesday. But if you got some, sorry, Wednesday. But if you have some time and you want to get after it, it is all stuff that you've seen before. Go for it. Oh, to do what now? Oh, there totally is. So you could do a linear regression. There's a way to do these. It's going to give you decimals, but there's a way to turn them into fractions too. Yeah, the calculator will do this for you. It ends up probably being more work to punch it into the calculator than to work it out by hand most of the time though. Give me a moment, I'll get this assignment up here. All right, so there's the assignments that I'm going to give you on Monday. Again, it's all quadratic stuff. We'll take notes on Monday. We'll do guided notes, but it's all stuff that you've seen. So feel free to chip away at that if you're feeling confident. And if not, if you finish today's assignment and you want to work on something for another class, just do something productive. Don't be disruptive. Ask me some good questions today. All right. Thank you.